Hey everyone, ready to explore an element that's both mysterious and surprisingly close to home?
You bet. We're diving deep into the world of Americium.
Americium. It's more than just a name on the periodic table, right?
Absolutely. Americium has a history intertwined with major world events and groundbreaking science.
Okay, so I know it was discovered back in 1944, but the transcript mentions these nicknames the scientists used: Pandemonium and Delirium. What's the story there?
Those nicknames, they really capture the struggles the team faced trying to isolate Americium from curium. It was a real challenge. They were really pushing the limits of what we knew about atoms back then.
Wow. So they're kind of wrestling with the universe's building blocks to get to this stuff?
That's a great way to put it.
It sounds pretty intense. And I read that the initial discovery was kept secret because of the Manhattan Project.
That's right. The Manhattan Project had a massive impact on science, not just in developing weapons, but fundamentally changing how we understand the atom. It led to a whole wave of discoveries and technologies like Americium.
Wow. Talk about a secret weapon. And speaking of names, Americium is pretty straightforward. Named after America, just like europium is named after Europe.
Exactly. It reflects a common practice in the periodic table. Elements with similar properties are grouped together, and their names often reflect their origins or the scientists who discovered them. It's like a built-in history lesson.
So we've got this element named after America, born out of top-secret science. But here's something that blows my mind. You can't just dig up Americium in your backyard.
Not quite. Any primordial Americium, the kind that may have existed when Earth formed, would have decayed long ago because of its radioactivity. The Americium we know today, it's mainly a result of human activities, things like nuclear tests and accidents.
That's both fascinating and kind of unsettling. It really makes you think about our lasting impact on the planet.
It does.
It's mind-blowing that they found Americium at the site of the first hydrogen bomb test. Ivy Mike.
Incredible, isn't it? It highlights the extreme conditions needed to create such a heavy element. We're talking about unleashing energy on a scale that forges new elements.
Now hold on. I also read about tiny traces of Americium possibly occurring naturally in uranium minerals. Is there any truth to that?
That's a possibility that scientists are still investigating. It shows how our understanding of the universe is always evolving. Even areas we think we understand well might still hold surprises.
This is getting cosmic. I even saw something about scientists thinking Americium might exist in certain stars, like Brazilski's star, an element forged in the heart of a star billions of miles away. It's insane.
It really underscores the interconnectedness of everything in the universe. The elements that make up our bodies, our planet, even distant stars, all come from the same cosmic origin. It's a beautiful thought. We are, in a very literal sense, stardust.
Okay, officially mind blown. Let's bring things back down to Earth for a minute and talk about how we actually make Americium here. It's synthesized, right? Mainly from plutonium-239, which comes from uranium-238.
Yes, but it's not as simple as just combining ingredients. Imagine a very carefully choreographed dance of atoms. We start with uranium-238, bombard it with neutrons in a reactor, it transforms into plutonium-239, which then goes through another round of bombardment, and voila, you've got Americium.
So it's a multi-step, high-energy process. That explains why it's so valuable and expensive.
Precisely. The scarcity and the complexity of production contribute to its high value.
Okay, now I'm picturing Americium. I read it has a silvery white appearance and tarnishes in air. Sounds like a precious metal.
It might share some visual characteristics with precious metals, but the defining feature of Americium is its radioactivity.
Right, of course. I read its density is somewhere between plutonium and curium, making it the lightest of the three. And it's also relatively soft and malleable compared to some other similar elements.
That malleability makes it easier to work with. But remember, handling Americium always requires strict safety protocols because of that radioactivity.
Now get this. Americium is kind of a chemical chameleon. It can have a range of oxidation states from +2 all the way to +7.
That's an impressive range for any element. It leads to some fascinating properties. Different oxidation states mean different colors depending on the chemical environment, almost like it can change its appearance.
And those higher oxidation states, +4 and above, are powerful oxidizers. How strong are we talking here?
They're about as strong as permanganate, which is a notoriously powerful oxidizing agent. That means Americium in those states can readily react with other substances, which makes it both useful and potentially hazardous.
Wait. If Americium is so difficult to make and potentially dangerous, why use it in something as common as a smoke detector? Are there safer alternatives?
That's a great question. While other types of smoke detectors do exist, americium-based ones offer a unique combination of sensitivity, reliability, and cost-effectiveness. The key is managing the risks through careful design and strict regulations.
So, Americium is actually in those smoke detectors we see every day. I never realized. I'm suddenly looking at them in a whole new light. What exactly is happening inside there?
It's all about harnessing americium's radioactivity for a life-saving purpose. Inside the detector, a tiny amount of americium-241 emits alpha particles. These particles ionize the air, creating a small electric current. When smoke enters the chamber, it disrupts that current, triggering the alarm. It's a testament to human ingenuity, using a potentially harmful substance in a controlled way for our benefit.
And there's even more to it. I read that a tiny bit of neptunium is slowly forming inside those detectors as the americium decays. It's like elemental alchemy happening right in our homes.
It is. It's a reminder that radioactive decay is an ongoing process. Over time, one element transforms into another, releasing energy along the way. It's a microscopic dance of creation and transformation happening right under our noses.
Okay, I have to admit, the idea of the nuclear battery still sounds a bit like science fiction to me. I'm picturing some glowing orb powering a spaceship. Is that even remotely accurate?
Well, it's not quite as dramatic as a glowing orb, but
Come on. You've got to tell me more. We'll have to save that for part 2, though. We're just getting started with this deep dive into the amazing world of americium. Don't go anywhere.
welcome back to our Americium deep dive. Before we get to those futuristic batteries, let's circle back to the safety concerns we talked about earlier.
Yeah, that's important. Americium is fascinating, but we can't forget, it's highly radioactive. We need to handle it carefully.
Exactly. In labs, working with americium requires special equipment and really strict safety procedures. It's not something to take lightly at all.
So what are the specific risks? We talked about how most isotopes emit alpha particles, and those are easy to block, right?
Yes, a simple sheet of paper or even your skin can stop alpha particles. But here's the thing. The daughter products from americium's decay, they often emit gamma rays and neutrons. And those are much more penetrating. They require heavier shielding to stop.
So it's not just the americium itself, but also what it decays into.
Got it. Precisely. And ingesting americium, that brings further risks. While most of it is excreted fairly quickly, a small amount can get absorbed into the bloodstream. It can end up in the liver and bones, which increases the risk of cancer.
Definitely something to be aware of. But I thought most of the americium we encounter is safely contained, like in those smoke detectors.
For the most part, yes. But improper disposal of smoke detectors can lead to americium leaking into the environment. And there have been cases, where people try to extract americium from smoke detectors, which is incredibly dangerous and should never be attempted.
It's a good reminder that even though americium in smoke detectors benefits us, we have to treat it with respect and dispose of those detectors properly. Okay, now I'm really curious to hear more about these nuclear batteries. They sound straight out of a sci-fi movie.
Well, it is a pretty fascinating concept. Instead of relying on chemical reactions like regular batteries, nuclear batteries use the energy released from radioactive decay.
So the americium is actually powering the battery just by decaying.
Exactly. The energy from that decay is converted into electricity. And that creates a power source that lasts a really long time and is very reliable.
I read that americium could power missions for hundreds of years. That's mind-boggling. What does that kind of power source mean for space exploration?
It opens up a whole new realm of possibilities. We could establish permanent bases on the moon or Mars, send probes to the outer solar system. We could even potentially go beyond our solar system to explore distant stars, all powered by americium.
So those glowing orbs powering spaceships in movies. Maybe not so far-fetched after all.
Haha, maybe not in appearance. But the concept is getting closer to reality all the time. Remember that experiment where scientists powered a light bulb using americium?
Yes. That was incredible. It seemed like such a big deal, but I didn't quite understand why.
It was a proof of concept. It demonstrated americium's potential to provide long-lasting, localized power for all sorts of applications. And we're not just talking about spaceships here. Think about remote sensors, deep-sea exploration equipment, or even medical implants. Imagine a pacemaker that could last for decades without needing replacement.
That's amazing. Like a tiny powerhouse with limitless possibility.
Exactly. And there's another intriguing application we haven't talked about yet. Americium as a neutron source.
Okay, you've piqued my curiosity. What is a neutron source, and what does americium have to do with it?
It all boils down to a nuclear reaction called the alpha N reaction. Think of it like this. You have a billiard ball, an alpha particle emitted by Americium-241 hitting another billiard ball, a beryllium nucleus, and that knocks a third ball, a neutron, off the table.
Okay, I can picture that. So Americium is like the cue ball, the beryllium is the target, and the neutron is the one that gets sent flying.
You got it. These neutron sources have a wide range of uses, from measuring moisture levels in soil to detecting explosives. They're even used in medical treatments, like radiation therapy.
Wow. It's incredible how this one element can be used in so many different ways. From everyday smoke detectors to cutting-edge scientific research and potentially even powering our future.
But there's even more. Americium plays a crucial role in creating other elements, ones that are even heavier than uranium. We call them transuranic elements.
So we've been throwing around this term transuranic element. What does that actually mean?
Transuranic elements, those are the ones with an atomic number higher than uranium, meaning they have more protons in their nucleus. They're synthetic elements, they don't occur naturally. They're created through nuclear reactions. And americium, through a series of carefully controlled reactions, can be used to synthesize elements like curium, berkelium, and californium. It's like a stepping stone on the periodic table, leading to the creation of these exotic, elusive elements.
These are elements most of us have never even heard of. What are they used for?
Many of them are primarily used in research, helping us unlock the mysteries of matter. But some have practical applications in medicine and industry. Californium, for instance, is used in cancer treatments and to detect explosives.
So it's like americium is the key to unlocking a whole new world of elements
Yeah.
with incredible properties and potential.
Exactly. It's a gateway to the frontiers of science, where researchers are pushing the boundaries of what's possible, both in terms of understanding the universe and developing new technologies. But one of the more down-to-earth applications of americium might surprise you. It's used in spectrometry.
Spectrometry, I vaguely remember that from science class, but how does americium fit into that?
Well, Americium-241, with its consistent gamma-ray emissions, is really important for calibrating gamma-ray spectrometers. These instruments are essential in all sorts of fields, from analyzing the composition of materials to detecting radioactive contamination.
So it's like a tuning fork for gamma rays, making sure the instruments are measuring accurately.
That's a great analogy. Americium-241 provides a known and precise source of gamma rays. It lets scientists fine-tune their instruments for accurate measurement of these high-energy photons. We've covered a lot of ground today, from smoke detectors to spaceships, from the heart of the atom to the vastness of space. But there's one more critical aspect of americium we need to discuss: its potential impact on the future and the ethical considerations that come with it. Join us for the final part of our deep dive, where we explore this fascinating element's role in shaping our future.
We're back for the final part of our deep dive into americium. We've explored its history, its uses, even its potential. But it seems like with any powerful discovery, there are always ethical questions to consider.
Absolutely, especially with something like americium. As we unlock its potential, particularly for space exploration and energy, we need to be mindful of the responsibilities that come with it.
So let's talk about those responsibilities.
Right.
What are the biggest ethical considerations when it comes to americium?
Well, safety is always paramount. As we've been discussing, americium is highly radioactive, so any use of it has to prioritize the safety of those handling it, and of course, ensuring minimal environmental impact.
We've already talked about those incidents where people try to extract americium from smoke detectors.
Right.
That's a perfect example of what not to do.
Exactly. Strict regulations and protocols are crucial. For the safe handling, transportation, and disposal of americium, we need to minimize the risk of accidents and contamination.
And what about the long-term environmental impact? Americium has a really long half-life, so where it ends up really matters.
It's a critical consideration, especially for things like nuclear batteries and space exploration. We need responsible disposal methods that prevent americium from building up in the environment and potentially harming ecosystems for generations.
So it's not just about launching a spaceship powered by americium. It's about considering the entire life cycle of that fuel source and its potential impact on Earth and space.
Precisely. It's about understanding the full consequences of our actions and making choices that benefit both humanity and our planet in the long run.
So the future of americium is about more than just technological advancement. It's about making sure we use this powerful element responsibly for the betterment of humanity. What does that future look like? What kind of possibilities can we imagine?
Well, think about our growing need for clean and sustainable energy sources. Americium-powered nuclear batteries. They could be a real game changer. offering a long-lasting and emission-free alternative to fossil fuels.
So we're talking about powering our homes and cars, maybe even entire cities, with these tiny but mighty batteries.
It's not just about replacing fossil fuels, it's about enabling new technologies that need compact, long-lasting power sources. Think about things like advanced robotics, artificial intelligence, or even those implantable medical devices. Imagine a future where pacemakers and other life-saving implants never need battery replacements.
It sounds incredible. And what about space exploration? We talked about how Americium could power missions for centuries. What does that mean for our future in space?
The possibilities are almost limitless. We could establish permanent bases on the moon or Mars, send robotic missions to the outer reaches of our solar system, and maybe even venture beyond, all powered by Americium. It's a future where we could become a truly spacefaring civilization.
It's pretty amazing to think about the potential. But as we've discussed, we can't just charge ahead blindly. We need to approach these advancements carefully, with a sense of responsibility for their impact.
You're absolutely right. The future of Americium isn't just about technological progress. It's about ensuring we use this incredible element ethically and sustainably for the good of all.
So from a top-secret wartime discovery to powering spaceships and potentially shaping our energy future, Americium has taken us on quite a journey.
It really has. It's a testament to the power of scientific curiosity, the constant pursuit of knowledge, and the responsibility we have to use these discoveries wisely.
It sounds like the story of Americium is just beginning, and it's going to be an exciting one to follow. Thanks for joining us on this deep dive into the fascinating world of Americium.